everyone. So this is testing the waters, or how to tame the alligators. One thing that's commonly said about a lot of code is that it's a bit like a swamp. So I'm Tom, also known as TB Sliver. I work at Shadowcat Systems as a developer, but I'm also tend to do a lot of DevOps, systems, project management, project architecture, everything else that's under the sun. So one thing that I end up working a lot on, large projects where they've got multiple moving parts, lots of dependencies, submodules, special requirements, and many other things. And with any large system, being sure that changing one thing doesn't break something else is always useful, but not always something which has actually been implemented. Of course, I'm talking about testing, but something I keep coming across is a lack of tests for the project. And I hear a lot of excuses. I mean, they range from things can't be tested, setting it up is hard, maintaining the tests is difficult, or we never got around to it. So that last one is probably the most common one I come across, but the others have happened fairly regularly. I come across a lot of time when the test framework doesn't run at all, and they're saying, oh yeah, our tests are fine. No, they're not. So I'm going to be going a few ways that I've made tests easier for other developers, and obviously making sure that there's no obstacles to actually proving that everything's working correctly. So I'm going to start off with a fairly simple example, and then extrapolate out on a bit, and then have a look at a few of the other little bits and pieces I've used, and tools I've either used a lot of or have written and released out on CPAM. Now, a lot of these, whoops, where's my drink? Now, a lot of these are going to be examples using web server and database style stuff, so Modulicious, Catalyst, that sort of thing. But obviously, a lot of these things can be extrapolated to do other kinds of software, so GUI software, other sorts of bits and pieces like that. I generally find Perl's used a lot more for web frameworks and stuff there. So something I've been working a lot recently is Modulicious. And a lovely thing about Modulicious is it comes with Test Mojo. And it takes a lot of the complexity out of setting up a lot of user agents and various other bits and initializing the application. So a fairly simple example is that one. In fact, that's probably the example that comes with every single automatic install of Mojo. So when you do a Mojo create, or whatever the command is, that's one of the tests it spits out, and it just makes sure that it works. Obviously, that's not very good, not very useful. Okay, it proves that root returns 200, but to do anything useful, we're going to need a database or something for that. However, to get that, we need the configuration file for that first. So how do we get our configuration file? Now, could just create a config file specifically for testing, put like a testing database in there or a connection handle that you know is going to be there. However, that limits you later on a lot more, because if one of your tests doesn't clean up for itself or crashes or dies horribly or your machine powers off mid-test, then you're going to have to rebuild the whole thing, and if you've missed something, it's going to cause havoc. So the first bit to do is to sort out the config file. So Modulicious takes a environment variable. Is that big enough? Yep. So first off, we need a config file for it, and obviously this is a little clue for later. We're going to be using SQLite based memory database. But I'll go over a couple of other options that you have for this later on. And note that the file seek at the very end, I think you can see that from the back. That's actually something that took ages to debug. You need to do that seek to the end, otherwise it doesn't flush the file and Modulicious can't read the file. That took a couple of hours to find, and I ended up diving through most of IOSeekable and various other file temp dependencies to find out what the problem was there. But anyway, so obviously the next step is to throw it into a environment variable. Mojo config is the one for Modulicious, and then just continue your test. Obviously here I'm just doing a standard ISA test against the config, and it's returning correctly. I actually think I've got the syntax wrong there. Never mind. It's a hash, not a object, but never mind. So the next thing is to obviously add stuff to it. Now, you've got an empty database, so now you need to deploy, you've got the config, now you need to deploy it. And I'm going to assume dbic, but you can use raw SQL or anything else like that if you really want to. I use dbic a lot of the time for this sort of thing. So first thing to do, create a table. This is in the back-end code. It's got an ID and a name for fruit, and an endpoint of /fruit that just lists them all. So populate your database. Quickly pull up the schema, deploy it, and then just run a populate across the whole schema. That's all well and good. And then you just need to add a new test. There you go. Check /fruits. Make sure that the JSON comes back correctly. You're done. However, now this test is about 3 times longer, and over 50% of it is bootstrapping code and boilerplate that you really don't need there for all the tests, and can probably factor out. I mean, if you've got one test that needs to do this and only does this bit, then yeah, fine, whatever. But if you've got 1,000 tests, that's a lot of lines. So let's move some of these bits out. So yeah, that's a bit bigger. Moving this across into a moo class, I've created a config file attribute and a mojo attribute, and it's otherwise the same. I use lazy attributes just because that's nice and easy and means that you don't end up with dependency resolution going AWOL. So if you set those both to read-onlys with the builder, it would just have a bad day. But obviously, it's a bit. I think it's an extra maybe 15 lines, but it's taken 15 lines out of a test. So as soon as you've got 2 tests with it, you've broken even. It also means that if you ever need to change the config, say you have an extra config part that's needed, you change it in this, and all your tests just carry on working, assuming you haven't completely broken it. So after that, it takes out a lot of that setup code. So you take out all the config bits and replace it with 2 lines, and then you've got the schema deploy as before. However, you've still got the database population. Now, there is a tool somewhere around for that. Enter dbx class fixtures. This is why I use dbic, because this tool is great, unless you find a massive bug in it. This creates a flat file structure from the data in your database that it can then repeatedly put back in when you give it and takes either a dbic schema or a raw DDL file. So you can actually use raw SQL files to do this. It shoves it in, deploys it, and then pulls it back out again. And with a bit of thinking, you can actually have multiple fixture sets, allowing for tests which focus on focus on specific examples. So you've got one which has got 2 things that are the same or something like that, or you need to test across a couple of other options like that. And it means you don't have to create one large test database that covers everything and may interfere with other bits. I mean, this may seem a little overkill, but when you have a larger system, you will be so happy you had this for various little tests, because it also means you don't end up killing any of your older tests with extra database parts. Obviously, definitely more useful later. So let's get a simple fixture script going. This is a basic fixture script. So we've got a directory for the configs, which is I actually put into my T directory, T etc. fixtures config, and that's just where it puts all the particular configs for whichever fixture you're doing. And then create the schema, pull up schema deploy, and then the ellipsis is where you do your population. You could also use a normal database handle and actually connect to a live database or a testing database you've already got and pull everything out that way. Then you don't have to populate it, and you just have to run the fixtures dump all. Create a data set, and with a bit of thinking, the file structure you can get can be quite flexible. I think my favorite so far is when I had 3 Postgres databases and 2 Oracle databases off one set of fixtures, all spinning up to do a weird synchronization script that somehow worked. And then obviously you just have to keep the paths correct consistent. Well, keep the paths consistent with your main framework when you're doing that. So this is a fairly standard pattern that I've been using for a long time. So with the fixtures created, you just need to do the population of the database. I've got a basic attribute for the etc.dir because obviously if you're in a test folder you might be using recursive tests, at which point the etc.dir is in a different location for each test, so give it where it should be for it. And then the fixture name, read-only required, and then build the fixtures config using file spec cat file because you might be running on Windows, and same with the data folder. And then you create the dbic fixtures attribute. So just that little top bit is just returns your dbic fixtures. And then inside the mojo part, you just shove in the dbic fixtures, populate directory you're looking for, tell it to no deploy because you've already got a schema that you've deployed and it has a bit of a hissy fit if you try doing a if you give it a schema and you haven't deployed it. And that's ready to use. So let's go back to our test, and that's it. That's all that code. 20 lines is now 5, and that's only because I like it being readable. That'll actually fit on one line if you're using some shorter bits. And you can have multiple different fixtures, multiple different things, and each test can possibly have their own fixtures, or you can have 5 things that work on the people table and 5 things that work on the fruits table and whatever. Doesn't matter. Maintaining them is fairly simple, and because it's a flat file, you can actually just go in and edit it manually. It's just a dumped hash, a Perl hash, just dumped to a file in alphabetical order. Now, obviously this example uses a Modulicious app as a basis of our test, but you can just as easily be modified to make it work for a Catalyst-based PSGI, or even an Apache-based application. Obviously, for these, you may have to pull a few more tools from my favorite toolbox, CPAN. I'm assuming everyone else's favorite toolbox. So some of the other modules that are available I use a lot. LWP protocol PSGI. It allows you to override the back end of any LWP-based module with a PSGI app. And you can also set the optional host name, so you can either capture every single request or just a particular one to a particular port on a particular host. When I was saying earlier about using SQLite database in memory, you could also use test MySQLD, which will actually give you a MySQL daemon and pass you back a DSN that you can throw into DBI, dbic, insert database system here, and then you can play with it and it'll spin it up. You can do what you want, do your test, kill it again. Same with test PostgreSQL. Not to be confused with test PostgreSQL. For some reason we have one with the proper capitalization and one without. The one without is actually a older version that then they released a version with the correct capitalization and meta CPAN and everything still caching it, so you might turn up. I don't know if they fixed that yet or if that's something on their fixed list, but yeah. The other one is a module of mine, which is test instance Apache. Which was done out of annoyance of having to try a test using Apache test. If has anyone tried using that before? Anyone come across Apache test? No? Yes? Maybe? Yeah, sort of. You wish you hadn't. Eye bleach. Mind bleach. Lots of beer. Yeah, it's not really fit for the purpose I was trying to do, so never mind. So, the first one I'm going to quickly go over is LWP protocol PSGI. It's actually ridiculously easy to set up. If you've done any tests with, in fact, there it is. If you've done any tests with test where we mechanize or test LWP user agent or any of the LWP based ones, you can actually, it just works. It just overrides it underneath, and you can turn it off again if you need to. Here you can see. You can see a few of the bits ones. I mean, obviously, with it being a PSGI app, this particular example is a web simple app I used. It actually does the same as the other one, but it was I found it easier to get to PSGI. And all you've got is the LWP protocol PSGI register, your PSGI app, and then return the test mechanizers you need. Obviously, this means you can do, if you can convert it to a PSGI app, you can do anything with it. So anyone up for Python FCGI under PSGI in Perl tests? I've done that. It's terrifying. I wasn't using inline Python because I needed it to work another way. But otherwise, the tests come out almost identical. Obviously, you don't get some of the nice syntax from Mojo, but standard mech to check you get the local host. And here you can see it's overridden. I didn't actually set which host name it was on, and it's just overridden HTTP localhost. I could do google.com, and it would still get to the right PSGI app because it's overridden everything. But that means if you've got multiple PSGI apps that need to talk to each other, you can actually do that inside there, and it does work. And can get really confusing if you get the port numbers wrong. But otherwise the same. So, next bit I'm going to quickly go over is a couple of the testing database bits. For MySQL, as I said before, there's testing MySQL, Postgres, test PostgreSQL. And with both of these, obviously, you need the particular underlying software installed. Obviously, you need MySQL or MariaDB, or MariaDB installed on your system, or Postgres installed, and then it just works. Or you could use an external system. Having done this, obviously Oracle Oracle database you can't really install on any on your personal machine unless you're running, I think, CentOS or something else, and it's a pain, absolute pain to get. So if you run it in VirtualBox on one of their personal testing ones, then you get yourself an Oracle system. But obviously, you've then got to figure out all your user rights and make non-colliding database names so you can run your tests in parallel because they take so long. But you can do it. It's as long as you just think about it, set your usernames correctly, or have a DBA that knows what they're doing. That's nice and easy. And you could also just have it have any database. Then you could have a Microsoft one while running on Linux or whatever. Although you can now run on there, but never mind. So, quick one, test MySQL. It's actually really easy to use. That's pulled directly from their page on MetaCpan. And it's just spin it up, tell it to skip networking because you don't need the TCP socket, plan your tests, and then just throw the DSN into your schema. So here you could do that instead of just using the SQLite in memory, just throw that in instead on another attribute in your framework, and there you've got a database. You can do it multiple times and have multiple databases. In fact, test MySQL supports multiple instances, and then you can go really crazy with that. Same with test PostgreSQL. Almost identical, you can probably just do a find replace on PostgreSQL from MySQL, and it will work. And then any extra configuration you need in there means that, well, you can do a hell of a lot on there. I think that there's a lot of options you can pass to that, but I'm not going to go into it because configuring Postgres is a lecture to itself. Now, the final one I'm going to quickly show is one of my own modules, which is Test Instance Apache. This one I wrote specifically because writing the tests with Apache Test was an absolute pain, because it's designed specifically for testing modules that run inside Apache, and your tests run inside Apache rather than testing the application behind it. So that was painful. And so for creating this, the configuration is same as you'd see in a normal Apache config. It's all done in arrays because it has to be in order. Throw the config together, tell it the modules, and tell it to run. And then that will run an Apache instance until Perl calls cleanup, and you can do whatever you want in there. If you're running stuff that's mod Perl based, you can just point test web mechanize at it, whatever, and it's nice and easy to do. And if you've got any weird configurations or you need to test something that's running on another system or another language, whatever, you can just spin Apache up to do it. And then you can test in your favorite language. So that's a short foray into all the testing stuff I've used and developed, and I hope that's been useful. Any questions? Did I see someone with a question? Oh, sorry.
It's not a question, it's more
Okay. That's cool. So that was just pointing out that you could, instead of having a test MySQL or possibly a test Postgres for each one, I don't know if it would work for that, but you could have one that it spins up at the beginning of your proofs run, and then it uses that database and it just passes out DSNs with guaranteed non-colliding database names. And that would also be a possibility. And that would decrease overhead. I have brought entire dev servers down when everyone tries running their test frameworks at once. Oops. If anyone wants to see any of the code, was there any other questions? Sorry, I forgot to check. I can't actually see, never mind. Anyone have any, want to see the code at all that was used in this? It's on GitHub, tbsliver/testing the waters. And thank you for watching. Find me on GitHub, Twitter, IRC, and on the internet. Thank you very much.